One I'm going to be talking about is the SageWrite corpus, which was created by me and my colleague Desara Xhura, who cannot be here. And this corpus was created to assist for text generation and automatic quality assessment of academic articles specifically. It's not working anymore. Okay, so we all know how it is to write academic papers. It's a very time-consuming process. We all hate it. And generally, when you write an academic paper, most of us, we start by writing a draft of content. So we write something that is going to look like something that you see to the right, to the left on your slide, on the slide. So you're going to have an initial draft of content, which is going to be very schematic, it's going to be very colloquial, and it's going to miss a lot of important things. So it's going to miss copulas, it's probably going to miss determiners as well. So it's going to be a version of the final paper that is very bare bone. And then eventually, after editing this and re-editing this and editing this again and again and again, we eventually get to this, which is the finished text. And if you just try to compare very quickly how the two texts compare, you see that, well, in the finished text, you got all the things. So you got all the words. We're no longer missing any copula and determiner, but also we've tried making the text more syntactically complex. And of course, it's much less colloquial than what we had in the initial draft. So what my colleague and I wanted to do was we wanted to try to automatize the process. So essentially, automatize the process that leads from having the draft all the way until having the finished paper. So teach machines how to take as input a draft of content and then automatically generate the finished text as a result. A second goal was to try and see if it is possible to automatically assess whether academic texts are well written or not. So develop a classifier that could do that kind of job. Enter the SageWrite corpus. So the SageWrite corpus is a corpus which is very much in the making, so it is still very small. We're trying to make it bigger. But right now it contains 100 manually annotated excerpts that are taken from real existing academic articles. And for each of these excerpts, the corpus contains two things. On the one hand, we've got a draft version of what that paper might have looked like. And I'm going to explain in detail what we mean by draft version. And we also have a series of annotations in the form of linguistic tags that reflect the stylistic and linguistic merits of the excerpt. So whether it's well written or not. So getting a bit more into detail about how the corpus looks like and what we did to create it. So as I said, what we care about is academic articles. So to annotate academic articles, we needed to start with a database consisting of academic articles that we could work on. So the way that we did that was we first created a data set containing articles from a variety of sources. So we took some articles from arXiv, some articles from PubMed, and then we also added around 70 articles from the humanities. And this is because arXiv and PubMed are mostly focused on the hard sciences. So you get a lot of papers from mathematics, computer sciences, physics, etc., etc. So we wanted to try to balance the subdisciplines represented in the database by including papers from theoretical linguistics, history, arts, etc., etc. So what we then did was we wrote a Python script to extract excerpts of around 300 words from different parts of different articles. So we wanted to represent not just, let's say, the text that you see in the main body of a paper, but we also wanted to include parts from the introduction, the conclusion, and all other sections other than the bibliography, of course. And we also made sure that we were extracting text not just randomly, so from the middle of a sentence to the middle of another sentence, but we made sure that we were always extracting text from the beginning of a paragraph all the way until the full stop. Our annotators were 3, so we had 1 AMA student, 1 postdoc, and 1 university lecturer, and we specifically chosen people that were involved in academia because we wanted to annotate academic articles. So we figured it was best to get people that have experience writing academic papers. All of them were native speakers of American English. So starting from the drafts, like I mentioned, for each of the 100 excerpts, we've got draft versions of what that excerpt might look like. So as I said, what we want to do is we want to automate the revision process. So we want to take a draft of content and automatically generate the corresponding finished text for the draft. To be able to do that, ideally, we would need a trained data set that contains pairs consisting of finished text, finished paper, and the draft version of that article. And of course, we can't really just go around and ask authors to just give us their drafts, because people don't really keep them, and also it's not something that they want to share. So the problem is that we need a data set that does not exist. This is why we decided to try to create this SageWrite corpus. Another option is to take finished articles and sort of generate automatically what the draft version of that article might look like, which is what we're trying to do at the moment. But the question is, how do drafts look like exactly? So we have an understanding of how we write drafts personally, and the kind of revisions that we make to a draft to make it into a finished paper, but that does not mean that everybody writes drafts the same way. So there's got to be some kind of individual variation that we were interested in exploring. So for example, how much shorter is a draft with respect to the finished paper? What kind of content is present in a draft that is not present in the finished paper, and vice versa. So there are existing techniques that we can use to sort of study how people modify a piece of text all the way to the finished version of that paper, but they are kind of time consuming. So for example, there is a software called Input Log that allows you to track changes that users make to text, but they do take a while to study. So for example, there is a couple of studies that are using Input Log to study how students make revisions to text, but they take months to build up. So we wanted to try to get as many drafts as possible in as short of amount of time as possible, which is why we created this data set. So our idea to sort of get as much as we could in a short amount of time as possible was to be a bit cheeky, I suppose, and we asked our 3 annotators to read the excerpts from the academic articles that we gave them and try to reverse engineer how the draft version of that paper might have looked like. So in practice, that worked as follows. So we showed annotators an excerpt like this. This is taken from a real article on some physiotherapy study. And we told annotators, okay, look at this excerpt and try to figure out how the draft version of that article might look like, and then write it down so we can study that. And for this specific excerpt, what annotator 2 came up with is what you see to the right. And if we just quickly compare, for example, the very first 2 lines, we see that in the original, we've got the copula word, which is missing from the draft. We also see that annotator 2 decided to abbreviate physiotherapy, so she's using the word physio instead, and then we're missing prepositions as well. Right, so for all of the 100 excerpts in the data set, we've got 3 draft versions of the original text, and this is because we asked all 3 annotators to annotate the very same excerpt. So initially, we thought we're just going to ask annotators to look and work on different texts. But then we figured it was interesting to see what kind of individual variation there would be between annotators working on the very same text. So what kind of information we would drop and how different that would be among annotators. The tags, so that's the second part of the data set, the other information that the data set contains. The goal here was to create a classifier, or at least to test the possibility of creating a classifier that automatically determines whether a piece of academic text is well written or not. And in order to do that, we wanted to explore what kind of tags are relevant to do that. So there are lots of things that we can check and we can look at when we're trying to determine if something is well written or not, especially in academia. So you can look at whether the syntax is easy enough for people to understand. You can look at the lexical richness. You can look at the flow of the paper, does it flow well or not? So there's a variety of things that we could focus on, and we wanted to see in practice which features work best. So the way that we did that was we asked annotators to evaluate each of the excerpts based on a set of tags that we provided them. So annotators were asked to read a text and then pick which tags they thought would apply to that text. And we had a total of 19 tags that I'm going to go through quickly. So you see the tags here. And if we skim quickly through the list, you'll see that we tried including tags that refer to different linguistic dimensions. So for example, we've got colloquial language, formal language. This refers to the lexical dimension. Tag number 8 and 9, abuse of passive sentences, excessively complex syntax. Those are tags that refer to the syntactic qualities of the paper. But we also have more broader kind of tags, such as tag number 11, pretentiousness, and tag number 12, engaging writing. So the way that we set up this tagging system is this. So I came up with 13 initial tags that I came up with based on my own experience or what would be relevant and based on the literature on the kind of mistakes that authors make in academic writing. Then we asked annotators to practice these 13 tags on 50 trial excerpts. And then we asked annotators to come up or to suggest if there was any tag that they felt was obviously missing. And based on their suggestions, we eventually also added these additional 6 tags that are suggested by the annotators themselves while working on the excerpts. So for example, you see number 17, non sequitur. I thought it was pretty smart and also very relevant in the context of academic writing. So annotation was done on a dedicated platform. So annotators will log in. They will be shown the excerpt that they were supposed to be working on, and they would write down the draft version of that excerpt, and then there was this list of tags that they could select, and they would just click on whichever tags they felt would apply to that specific text. Then they would hit next, and then they would be shown the next excerpt. As I said, all annotators worked on the same excerpts, so they created drafts and they tagged the very same excerpts. And here again, this is because we wanted to see what kind of variation there would be among different annotators, both in terms of how they wrote the drafts and in terms of the kind of tags they would select for a specific excerpt. Specifically, what annotators saw was a rotation consisting of one excerpt taken from PubMed, one excerpt taken from arXiv, and then one excerpt taken from the humanities data sets that we had. Okay, so quickly, I'm going to go through some of the data, some of the insights that we can gain from this data set, starting from the tag usage. So as I mentioned, we want to see what kind of tags would be relevant to classify an academic article as being well written or not. So we wanted to see which tags were used a lot and which tags were not so very well used. So this table shows you exactly that. So it tells you how many times each tag was selected. And you see that we've got some tags that were pretty well used. So we've got overly long, sorry, not this one, opaque writing, which was selected 34 times. Then we've got clear structure 36 times. And then finally, word choice was also fairly well selected 18 times. Tags, they were not still used, so they were relatively underused, where colloquial language only selected twice, formal language only selected once, abuse of passive sentences 3 times, repetition twice. So these are tags that we could perhaps drop in the next round of annotation to make sure that we have a list of tags which is as essential as possible. And we were debating why, for example, annotators decided not to use these tags, colloquial language and formal language, and we concluded that colloquial language is perhaps not a feature that you encounter so much in academic texts. Formal language, we thought it might be because there is an expectation to be very formal in the way that you write academic text, so it's difficult to define when you're overdoing it, right? So that would perhaps prompt annotators not to select this tag because they thought, okay, this is very formal, but maybe academic text is really supposed to be this way. Another thing that we were very interested in was the length of the draft, and this is with an idea of potentially taking finished papers and automatically generating a corresponding version of that text that resembles a draft. So to be able to do that, we also need to know how the draft is different in terms of length with respect to the original excerpt, which is why we wanted to study what annotators did in our data set. And you see that there is definitely some variation in the way that annotators create drafts. So for example, you see that for annotator 1, the draft was around 77% of the length of the original text, but there is a difference. So annotator 2 goes for 81% and annotator 3 goes for 63%. So there's definitely a variation there as well. That information is also reflected in the average amount of words per draft. So the original had around 119 words per excerpt. And then in the drafts, we have variation when it comes to the amount of words. So for annotated 1, we have around 146 words. For annotated 2, we have around 155 words. And then finally, annotated 3 wrote the shortest drafts. And for him, the value was 119 words. We also calculated the ratio of unique words, so the percentage of unique words over the number of total words. And here I think it's quite interesting to see that this number is the same for the original texts and for the drafts created by annotator 1 and annotator 2. So you see for the original texts, this value is 22%, and for the drafts by annotator 1 and the drafts by annotator 2, it's also 22%. On the other hand, we've got annotator 3, who's the university lecturer, that has a higher value of 27%. Other things that we could get out of this data set that I've either not included here or it's something that we haven't looked at yet are the following. So one thing that is interesting to see is the frequency in the use of different parts of speech in the draft versus the original. And this is interesting because I mentioned in the beginning that the draft generally contains, for example, fewer prepositions, fewer copulas. So it's interesting to see the difference in the way the different parts of speech are used. We also saw that there was an abbreviation used in the draft by annotator 2 that I showed you. Thank you. So it will be interesting to see how often abbreviations are used in drafts, but also what kind of abbreviations are used. Are they abbreviations that are recoverable, or are there abbreviations that are just used by a specific speaker, and so it's difficult to make a rule out of those? And then finally, one thing that we could also be looking at is the difference when it comes to the usage of different tags by different annotators. So is there inter-annotator agreement, or is it not possible to see any kind of trend in that respect? And that is it. Thank you very much.